Hello and welcome to another special episode of the Space Update. Coming up on today's show, we'll be chatting with Richard French, Director of Business Development Strategy, Space Systems for Rocket Lab. Thanks for joining us today, Richard. How are you doing today?
Doing well. Thanks for having me.
Great. And before we get started, also joining me on today's show is...
I'm Astro Rodi, host of STEM Study.
I'm Mikko, the host of Deep Dive Fridays.
Thanks for joining us, guys. So, Rocket Lab, I'll just give you a brief overview. Rocket Lab are enabling companies, students, scientists, researchers, governments, and entrepreneurs to get their ideas into orbit right now. A solar system of possibilities has opened up for people who have thought space was out of reach until now. The satellites Rocket Lab build, launch, keep countries connected and borders protected. They're monitoring weather, managing waste. They're providing insights on climate change and helping us manage resources for the future generations. By unlocking potential for space, Rocket Lab is helping to make a tangible difference to life right down here on Earth. Thanks for joining us again, Richard. Do you want to give everyone a brief overview of your role in Rocket Lab and just a bit of background on the company itself?
Sure, yeah, very happy to. So I think, folks primarily know Rocket Lab so far as the global leader in dedicated small launch. But we're working to shift the narrative. My role as a director of BD and strategy for our Space Systems division is all about moving up the value chain with our integrated satellite system, which we call Photon, as well as down the value chain with our merchant component supply business. So we want to be a good ecosystem partner and be able to expand our offering and partner in new ways in support of that. Broader vision of going to space to improve life on Earth.
Absolutely fantastic. And Photon, the satellite bus, is absolutely incredible. I mean, it essentially enables scientists alike from around the world to essentially it's a plug-in-and-go system. Photon already has the power, the communications, everything. I'm sure there's been similar things in the past, but I think Rocket Lab have essentially made it possible for the everyday scientist, if you like, being a small private company that Rocket Lab is.
Yeah, that's right. There had always been a vision to do satellites. When Pete created Electron and that bit at the top, the kick stage. And so after, a few flights and getting a lot of heritage in key subsystems like propulsion, we were able to make that jump into satellites by just adding a few key subsystems like solar panels, upgrading the radiation tolerance of the avionics and such. So it's been great to get our first few photons up into space and really demonstrate that we can take advantage of our unfair advantage of having a rocket that's flying regularly. And it's been pretty incredible to see the response of the community, across industry, government, civil space, and national security for interest in Photon.
That's incredible. Just to kick things off with the topics we're going to run through here, obviously you've got missions, Moon, Venus, Mars, and so much more, but you've recently got a contract for the NASA Escapade mission to Mars, which is essentially 2 custom-built satellites to go to Mars. Can you tell us a bit more in Rocket Lab's involvement to the Escapade mission?
Absolutely. So NASA Escapade it's an amazing planetary mission, but also is actually a heliophysics mission. So it's going to Mars, but the project's actually being managed by the heliophysics division. So it's a pretty exciting partnership between two key science divisions. If you're familiar with the Simplex program, it's really the small satellite planetary science program for NASA. And Rob Lillis, our PI and the leader of the project, was selected under a previous solicitation, and we had the honor of getting to compete for the spacecraft bus. And so one of the reasons that we're really excited about this is it shows the ability to customize or configure this spacecraft for really challenging missions. And that's really what we're after. We want to be known as a company that can solve hard problems. And this one is pretty hard. We're going to launch on a ride share And so first problem, we've got to get ourselves to Mars. And so that's pretty tough. Once we get there, we need to stop and get into orbit. And then once we've accomplished that, there's a science mission to complete, which is to study the unique magnetosphere around Mars and how it's evolving, and how the particles in Mars's tenuous atmosphere are actually escaping and interacting with that magnetic field and the solar wind. And so there's really important analogies there for climate change and processes that could be happening here on Earth. So yeah, we're super excited to be supporting Rob and his team at SSL.
Yeah, that's fantastic. Could you tell us a bit more about the ESCAPADE mission? Will the Photon be used as such, or will there be a lot of customization for the customer?
There's always customization, so that's really we've architected Photon in a way that we can configure it on a per mission basis. So whether it's the engine that we use, whether it's the Curie or the HyperCurie engine, the sizing of the propellant tanks, the power system sizing, and then other aspects. This mission will fly on another launch vehicle integrated onto an ESPA ring. And so, the loads that it experiences cantilevered off of an ESPA ring are very different than the loads that we experience when we're vertically integrated on Electron. And so being able to meet those structural requirements, but in an architecture that looks similar is challenging. So all the engineering required to make the architecture compatible with these different launch approaches is an example of that configurability or customization.
Nice. So the mission's built to launch in 2024, and you just kind of went into a little bit of the rideshare. Do you know who else will be on that? And is launch provider locked down at this point? And can you tell us that?
I can't tell you because I don't know. So the launch is going to be provided by NASA, and we're working to a set of assumptions on what that launch opportunity will look like, but it has not been selected. And that's one of the challenges for these rideshare missions, is to design a mission that works within the context of that uncertainty. And it's one of the things that we can meet that challenge because of our propulsion systems and that configurability to provide flexibility on launch options. So we'd love to know who we're flying with, and we can't wait for that selection. But we're designing for a range of options today.
Obviously, you got that ESCAPADE mission going to Mars and everything. Has Peter stated anything that he might want to send there himself, whether it be just a little keepsake, plonk it to Mars, or whether Rocket Lab's going to send its own mission there?
Well, I think if Pete were here, and I'll channel Pete a little bit, he would say his favorite planet, of course, is Venus. I think my goal is to go everywhere, and so I'm starting to think about Phobos and Deimos and near Earth objects, asteroids, and I think a sort of holy grail of the inner solar system would be to go back to Mercury, which we've got some interesting advanced concepts that we're thinking about there. But this is a NASA science mission, ESCAPADE, and there's a lot of rigorous requirements to meet. So JPL and others have had some fun with previous Mars missions and putting some Easter eggs in. So I won't allude to any fun that we'll have. But what we're really working to do is to meet the rigorous requirements of that program and deliver on the science as our primary objective.
And undoubtedly you'll have an epic name for that mission. Well known for quirky little mission names and everything. That's absolutely great fun.
Yeah, I always look forward to seeing what the next Rocket Lab mission is going to be called, because it's always a little bit tongue in cheek and entertaining.
Yeah, and the whole company gets involved in that. There's naming competitions for all the missions, and so it's pretty cool to be able to engage everybody and see the ideas that come out.
And for the newly announced Escapade mission, what challenges would that bring for Rocket Lab and Photon? Obviously, we had Photon tested in orbit around Earth and everything, but Mars a lot further away, a bit more challenging for the solar panels in terms of recharging and everything. What about communications and everything and the download links? Will that be a challenge, or will that be helped with NASA communications?
Yeah, good question. Communications is a huge challenge at Mars. We have some pretty exciting developments that we're doing internally that we hope to announce in the coming months, actually, that will enhance our component product offering there. But we're not quite ready to talk about those yet. But as far as the satellite side, yeah, we've got some unique capabilities that are required to enable deep space communications and navigation. So when you're not under the GPS constellation, you have to use radiometric navigation methods to figure out where you are. And that's a pretty challenging capability for any company to build up. But of course, the Deep Space Network is a key part of that, and that will be provided by NASA and really is essential to closing the link. There are a lot of other challenges, though. We've launched 2 satellites. Very successful, huge learning opportunities. We've got more satellites in the backlog. I think you have seen our LOXSAT-1 mission, which we're working with a company called Eta Space. It's a tech demonstration mission, and so those are really cool because you can take a little bit more risk with technology demonstrations. But when it comes to a science mission investigation, the risk posture changes a little bit. And so, we've been working over the last 7 or 8 months to prepare for the preliminary design review of Escapade, which was held last month, and we passed. And so it was a huge technical milestone, a huge pressure test for our engineering team to meet the technical threshold that a NASA standing review board imposes on such a project, and there's a lot of interest in us because we are a new company. We do need to prove ourselves, but there's also a lot of excitement to build collaboration with the new partners. So we hope that we're meeting the challenge.
Yeah, absolutely incredible. And just to fast forward a little bit closer to, obviously we've got 2024, the Escapade mission, but later this year or potentially next year, we've got obviously got Capstone to the moon, all to do with the Artemis program. That's absolutely fantastic, that one. Can you tell us a little bit more on Capstone and what Rocket Lab's doing to assist NASA with this?
Sure. This is of course really the first big challenge that we're working through, and all of the investment, all the engineering to deliver on Capstone then is being leveraged for Escapade. So at a high level, we're providing a launch service to the Capstone mission. So there's a spacecraft that NASA has funded, and they want to put that on a trajectory to the moon. And so that's the mission that we've signed up to, is to put their spacecraft on a translunar injection. But to do that with a small rocket, the approach is very different than when you use a large rocket. And so we basically need to use a full photon satellite to execute our mission concept over a series of about 8 days. And what we do is we launch into low Earth orbit, and we slowly raise apogee while doing orbit determination and calibrating the propulsion system, so that when we execute that final burn, we very precisely target the lunar trajectory. So that's kind of in a nutshell what we're trying to do. Of course, the mission is super important because more broadly it's about demonstrating communications and navigation technologies in the near rectilinear halo orbit in support of the Artemis program. And of course, super cool to be the very first launch of the Artemis program. And so we're doing our best to get that mission to the launch pad and then build on those capabilities with future opportunities.
That's fantastic.
Yeah, awesome. And you were actually talking about the burns on orbit. Will this bus use bipropellant, and will it be the first time with bipropellant?
No, we fly bipropellant regularly today with the Curie engine. The Curie engine is cool because it can operate in monopropellant mode as well, and so that's a really nice flexibility. But the Capstone engine, the HyperCurie, is a bipropellant engine. What's different about it from Curie is that instead of being pressure fed, it's actually pump fed. So we didn't talk that much about Electron or the Rutherford engine, which is an electric pump-driven LOX-Caro system. But we were inspired by that with HyperCurie to develop that same kind of concept. So we're using electric pumps to feed the propellant into the engine, and so that's basically the idea behind HyperCurie.
Nice. So the Cube satellite will share the same orbit as Gateway once operational. Will the satellite be destroyed, or will NASA continue its operation with this satellite?
That's a great question. I don't know what the kind of long-term plans for that satellite are. I detect that they're putting as much propellant in it as they can to offer residual capability. But every spacecraft that launches in general and in particular for NASA missions has to have an end-of-life disposal plan. And so I expect that once they meet their tech objectives and squeeze every bit of capability out of the mission, that they'll properly dispose of the spacecraft so that it doesn't represent a hazard to future missions. And that's actually what we plan also to do. So we'll be on the same translunar injection and lunar transfer that the payload is on. And so we'll take advantage of that to try to do a lunar flyby and basically shake out the deep space capabilities that we want to then use on ESCAPADE and other missions in a lunar flyby. And so we'll fly by the moon and actually come back to Earth and dispose in the Earth's atmosphere. So the Capstone spacecraft will probably do something similar to that, either dispose at the moon or into heliocentric space.
Watching the playback from the launch earlier on this morning, we saw Peter hint at that he might want to potentially send Photon to asteroids in the near future. Obviously, maybe not discuss that too much internally. Peter just recently mentioned that he might potentially want to do that. So won't press you too much on that one. But obviously, Peter's a big fan of sending something to Venus. I feel like it's been one of the most neglected planets, because obviously Mars has had a lot of attention, the moon's getting a lot of attention, obviously with the moon landings in the near future and everything. Rocket Lab are focused on sending something there. Can you tell us a little bit more on this as of yet, or is it still very much in the planning and research stage?
Yeah, for sure. I will, touch on asteroids for a second because I happen to really like asteroids, and you may be familiar with the Decadal Survey, which is ongoing with the national academies, and we think that dedicated small launch with Electron and small satellites with Photon will be a really important tool for those asteroid missions and potentially even interstellar object missions. And so we did some really cool mission design work to look at, can we get a spacecraft close to one of these objects that is discovered, and we sort of have this short window to launch. And so that rapid response and opportunistic near Earth object science is super compelling and a really good fit for what we're doing. So I was actually really excited to hear, Pete plug asteroids last night. But yeah, Venus. We've been pretty vocal about wanting to do our part to advance the search for life at Venus, and so we're working on it. We've notionally baselined a hyperbolic mission that would launch on Electron and follow that same escape plan that we're using for Capstone, and then when it gets to Venus, we would target an entry interface and actually separate a small probe that then would go and do the science and get into the cloud layer and search for life. So it's a high risk, high reward opportunity that is sort of incrementally builds on the capabilities that we're developing. It uses a lot of the same deep space communications and navigation capabilities that we're developing for Capstone or for Escapade, and then of course the same vehicle and Photon that we're developing for Capstone. So that the focus really is on the probe, on the instrument suite, and that new piece of engineering.
Fantastic.
Awesome.
Any updates on companies or agencies joining Rocket Lab for all those rides to Venus, or is it just purely going to be a Rocket Lab mission at the moment?
I can't talk in too many specifics about the collaborations that we're planning there, but suffice it to say we're very open to collaborations with other organizations, and I think that's essential. Actually, science missions and science in general is not it's not a solitary endeavor. You want to bring a community together to support the hypotheses development. Understand how the specific instruments and the implementation will actually advance science, and then, of course, help de-risk it. So there's new technologies and new capabilities required to be successful on this mission. So, yeah, we're very open and actively developing those conversations.
Obviously, prior to Rocket Lab, you did work for NASA, JPL, and you did have a little hand in the Curiosity rover, from what I hear.
Yep, a very small hand in it. I mean, I've always known that space was going to be my thing from middle schooler. It was always going to be aerospace, and so going to Michigan and getting pretty deep into aerospace there, coming out of school, not really sure where I wanted to go, but when I interviewed at JPL and they asked the simple question of how would you like to help land spacecraft on other planets? Okay, yep, that's the right
question.
Place to go. Very simple answer. So actually had the opportunity to do that. So I joined the Entry, Descent, Landing Systems Engineering Group. So initially supported the Crew Exploration Vehicle four-body heat shield development, which was pretty amazing to get to know the human spaceflight side of NASA. Really huge collaboration across the entire agency, and then being a member of the EDL systems team. I mean, they're giants on that team. Miguel San Martin, Adam Steltzner, my technical mentor, Eric Slimko. And so, just being able to be in that room and see that team do what it did was once in a lifetime career opportunity. Went on to be a subsystem lead on the soil moisture active passive mission. So learned about synthetic aperture radar and climate change. And so, had a great flight project experience at Jet Propulsion Lab.
And if you would say to anything to the young kids watching this, because we do have some young viewers watching our shows, what would you say to them who are looking for a career in space?
I really encourage hands-on exploration. People that know how to turn a screwdriver. Obviously, being good at math and having the academics is important, but those engineers that have actually built stuff, either electronics or, mechanical systems. I mean, software was kind of always my weakest point. If I could go back in time, I would tell younger me to work a lot better on developing my coding skills. But just to have that passion to actually see things, built and deliver something, make it real is pretty typical advice.
Yeah. Do you want to come in with anything, Joy, Mikko?
Just a huge congratulations to you guys for return to launch this morning and a successful flight. Big thank you for taking the time out of your busy day to come and chat with us and let our fans know a little bit about what you are doing there. And it's just fantastic. Hopefully we can do something like this again in the future.
Yeah, thank you very much. Obviously, a huge effort by our launch team and the entire company to, once again, troubleshoot an issue and get back to the launch pad in record time. It really is amazing to watch this team work. It's something that when I decided to go into the private sector, I was a little unsure what I would find in a commercial space company, but it was pretty clear when I started to get to know this team that they had the chops to deliver on these types of systems. And yeah, you saw it again this morning. And yeah, very happy to be here. Would welcome another opportunity to chat.
Yeah, definitely. But thanks so much, Richard, for joining us today. Hope you have a great day and everything, and we'll hopefully chat with you again soon. Thank you everyone watching the show today, and I'll catch you next week.
Thanks.